Well, good afternoon. With just a few days left here, we're going to focus tonight on motion review. So what do we need to know about motion? First of all, S of t or x of t represents the position. Displacement is the change in position. So again, you could say x of b minus x of a, but maybe make a note for yourself. It is the change in position. We need to know total distance traveled, which is the integral of the absolute value of velocity. We need to know speed. Now, speed is just the absolute value of velocity. So what's the difference between speed and total distance traveled? Well, again, total distance you're integrating, where speed is just the absolute value of velocity. Velocity can be represented by v of t, or the derivative of position, so s prime of t, or really x prime of t, depending what you're using for position. The word's average velocity. Now we want to make sure we get the whole formula written out with this. Average means I'm going to do 1 over b minus a, the integral a to b, and then who am I averaging? Well, that's the next word. So I'm averaging velocity. Now, according to the first fundamental, let's clean that up a little bit. If I integrate velocity, I get the change in position. And then because this is times 1 over b minus a, this will be over b minus a. But we should be able to write that whole equation out when we say average velocity. And then we determine which one is more appropriate. When is speed increasing? Well, speed is increasing if v of t and a of t have the same signs. I have to apologize for my pen here. It's kind of dying. Speed is decreasing when v of t and a of t have different signs. And then our big one, direction, is all about velocity. So what can they refer to? Well, remember, direction can mean to the right, and that's when your velocity is greater than 0. Direction can also mean to the left, and that's when my velocity is less than 0. But direction can also be when you are resting or not moving, and that's when your velocity actually equals 0. So we're going to run through some examples here, starting with example 6. A particle moves along a horizontal line so that its position at any time t is greater than 0 is given by this function, where x is measured in feet and t is measured in seconds. So first of all, when we talk about particle motion, I always like to think of like a squirrel on a wire, okay, or a bird on a wire, but mostly a squirrel. Basically, this squirrel can run to the right, and it can run to the left. It can stop moving. But notice it's not going in any other direction. It's basically going to the right, to the left, or not moving. So that's what you want to picture when you think of these particle motion problems. So part A says find the displacement. Well, if you look back in your notes about what displacement means, we said it's the change in position. Now notice it says the first 3 seconds. So I'm going to say it's the position at 3 minus the position at 0. So to evaluate that position at 3, I'm just going to plug 3 in this equation. So what does that get me? 9 minus 12 plus 3 minus the position at 0, which is just 3. So that looks like a total of negative 3. So my displacement, or another word for that, maybe make a note for yourself, is the net change is negative 3. B, find the average velocity during the first 3 seconds. Okay, so I'm going to set up average 1 over b minus a, so 3 minus 0, integral 0 to 3. Who am I averaging? We'll just read the next word, v of t dt. Now, don't stop there. Finish. According to the first fundamental, if I integrate velocity, I'm getting that position at 3 minus the position at 0 divided by 3 minus 0. Now, what's more applicable in this problem, the left side or the right side? Well, what do I mean by applicable? Who do you know? Do you know something about the left side or the right side? Well, I know something about position, which is the right side, so I'm actually going to cross this off and evaluate this. Now, I already did x of 3 minus x of 0 in the previous problem, so I know that's really negative 3 over 3, or 1. Now, let's talk units. The position, they said, is measured in feet. So this x of 3 minus x of 0 is negative 3 feet divided by 3 minus 0 seconds. So I should get feet per second. Part C, find the particle's initial velocity. So let's take care of that word initial. When something is initial, it's when it begins. So basically what they're saying is when t equals 0. Initial is when something begins. So find the particle's initial velocity. Well, they're really saying just find the velocity at 0. Well, again, I'm given position, so I'm quickly going to find just the velocity equation by taking its derivative. So I've got 2t minus 4, and then I'm going to evaluate v of 0. So I get negative 4. And its velocity at 3, so I'm also going to evaluate the velocity at 3. 2 times 3 is 6 minus 4 is 2. Now let's talk units. If, again, position was measured in feet, then this would be feet per second, as well as this one, feet per second. Part D, find the acceleration. So again, acceleration is the derivative of velocity, so a of t is equal to just 2. Now it says when time is 3. Well, notice, is there any place to plug 3 in? No, so guess what? The acceleration is always 2. Now again, let's talk units. If velocity was feet per second, and I derive, I should be getting feet per second, or feet per second squared. And again, I'm sorry about this pen. Part E, at t equals 3 is the speed of the particle increasing or decreasing. So now speed's the key word. Speed is when I have to compare velocity at 3 and acceleration at 3. So I think we already found the velocity at 3 back in this previous problem, so we know the velocity at 3 is 2, which is basically greater than 0, that's all I care about. And the acceleration is always 2, which is greater than 0. So again, make a note, I'm not going to write it all out here, but since v of 3 and a of 3 have the same signs, then we can say the particle is speeding up. Notice I said v of 3 and a of 3, not v of t and a of t. Letter F, during what times is the particle moving to the right? So again, if you look back in our notes there, we said anytime we see movement, we have to think velocity. And if I'm moving to the right, my velocity is greater than 0. So if I grab that velocity equation, scanning back into my notes, 2t minus 4, and I'm going to set that equal to 0, and I'm going to get t equals 2. Okay, so I've got my critical point, and I'll do a quick check to see when it's moving to the right. If I plug a 3 in my velocity, I get a positive. If I plug a 1 in, I get a negative. Therefore, I would say from 2 to infinity, my velocity is moving to the right because v of t is greater than 0. It's moving to the left. I can clearly see from negative infinity until 2 because v of t is less than 0. All right, in example 7 here, we'll take a look at a graphical approach. The graph above shows the position y of t of a particle. So I'm just going to be very clear and label this y of t, and this is the position. In inches, there's my units, moving along a vertical line. So now when I say picture a squirrel on a wire, well, our line is vertical. So I can't go left and right, I can go up, I can go down, and I can stop moving so I can come to rest. So those are my 3 big keys: moving up, moving down, or resting. And our time is measured in seconds. So A says, on what open interval is the particle moving down? So again, anytime I see movement, I have to be thinking velocity. So in my gut, I'm saying my velocity has to be less than 0. Well, now I have to say, okay, who am I staring at? This happens to be position. So if I want velocity, what am I going to look at on the position graph? Hopefully you've said it, you're going to look at its slope. So I'm looking to see when my slope is negative. So I would say from 2 to 4 and 6 to 7. And again, that's when v of t is less than 0. Beyond what open intervals is the particle at rest? So again, this is about movement. Left, right, and resting. Those are your 3 movement words. If I'm not moving, if I'm resting, then my velocity is exactly 0. So I'm looking to see when I have a velocity of 0. Again, this is position. If I want velocity, I'm looking at the slope to see when the slope is 0. So I would say it happens to be 0 for a section of time from 0 to 2. And we'll put a note of seconds in there. All right, part C, at what time does the particle change direction? So you're getting the idea. Again, the word direction, this is all about velocity. So that's when v of t changes signs. Oh, this pen. When v of t changes signs. So I'm looking at the slopes and I'm saying, okay, when do the slopes change signs? Well, if I went from 0 to negative, I did not change signs. I have to change from a negative to positive or positive to negative. So here I'm negative to positive, so I would say 4, and positive to negative, so 6. So hopefully you're saying at t equals 4 and t equals 6. All right, keep chugging here. During the first 6 seconds, what is the particle's displacement? Explain what this means in terms of the particle's change in position. So my displacement in the first 6 seconds would be y of 6, the position at 6, minus the position at 0. And let's see what we know. The position at 6 is 0, and the position at 0 is 6. So I would say my displacement is negative 6 inches because my position is measured in inches. E, during the first 6 seconds, how many inches does the particle travel? So again, I'm asking for how far it's traveled, so that would be the integral of the absolute value of velocity from 0 to 6. And I'm just going to set that up and kind of move on to the next one. F, what is the particle's velocity at t equals 5? Explain what this means in terms of the particle's movement. So I'm going to go back to my picture, and remember this is position, and I want the velocity at 5. So I'm basically saying, what is the slope at 5? Well, remember, 5 falls on this line, so anybody on that line is going to have the same slope. So I basically just need to find the slope of that line. So I know I have the point 4, negative 6, and I have the point 6, 0. So I would say the slope of that line is 6 over 2, which is going to give me a slope of 3. And since it's slope, it's going to be feet per second, and I just have to correct that, inches per second. F says what is the velocity, or G says what is the velocity at 5.999, and then at t equals 6. So at 5.999, it's still on this line, so I would say its slope is still 3 inches per second. Now what is the velocity at 6? What is the slope at 6? Well, notice it's coming to that sharp corner. So I want to be very clear that at t equals 6, the velocity does not exist. And what's our justification for that? Well, the limit as x approaches 6 from the left of y prime of t does not equal the limit as x approaches 6 from the right of y prime of t. And let's just watch our notation on that. Letter H, during what open interval is the speed the greatest? So now we're just talking speed. So remember, the speed is the absolute value of velocity. So I just want to know, when is the velocity the greatest? So I'm going to go back to my picture, and again I'm looking at the slopes to talk about when the absolute value of velocity is the greatest. So I'm going to calculate the slopes of each one. So in this first section from 0 to 2, I have a slope of 0. In this section, this whole line has the same slope. So let's see, if I go down 12 and over 2, looks like it has a slope of negative 6, but remember it's the absolute value, so its slope is actually positive 6. I already know this guy has a slope of 3, and if I calculate this guy has a slope of negative 3, which again, the absolute value is going to make it positive 3. So which of these has the greatest slope or the greatest velocity? I would say this interval from 2 to 4. And lastly, part I, what is the particle's acceleration at t equals 3? So let's go back and take a look at what we know. At t equals 3 here, we know the position is 0. We know the velocity, the slope of this whole line, so the slope right at 3 is equal to 6. So what does that tell you about the acceleration? Well, if the velocity is a constant 6, then its slope, or its derivative, is going to be 0 because it's a constant. I know that the acceleration at 3 has to be 0. Well, that does it for us on our quick review of motion, and we'll have some great practice tomorrow. Have a great night.